Hi, I am Joseph-Andre. I work as a blockchain engineer at Zama. In this new release of fhEVM, we introduce the new asynchronous decryption feature. A smart contract can initiate decryption requests via an oracle and then receive decryption results through a callback function. This new feature aims to optimize the efficiency and scalability of operations on the blockchain. It is also possible to request multiple decryptions at once in a single request. To use this feature, your smart contract should inherit from Oracle caller. Once it extends Oracle caller, it would also load automatically the Oracle library. You can use the request decryption method from the Oracle library to ask for data decryption. This method enables you to make a decryption request and specify a callback for handling the response. Additionally, it's possible to pass parameters to the callback function. Let's see now a concrete example in Solidity code. First of all, notice that our custom contract extends the Oracle caller contract, which is also where the Oracle library is located. The request decryption method from the Oracle library is used to emit the request decryption event, which will signal to the Oracle relayer that a decryption was requested. This request decryption method takes 4 arguments. The first argument, CTS, which is an array of ciphertext to be decrypted simultaneously. The second argument is the custom callback function selector, which should be called by the Oracle when returning the result from decryption to the contract. A message value as third argument, which is null here because the callback is not payable. And a last deadline argument to ensure that decryption should not be fulfilled too late. Furthermore, the request decryption function will return an unsigned integer request ID, which is unique for each new request. Also, we can use helper functions such as addParams euint in this example, which allows us to pass additional custom arguments, which are later used inside the callback via the getParams euint function. Those functions take the request ID as a first argument, and the addParams functions will store the additional arguments inside the storage of our custom contract to persist them between the decryption request and its fulfillment. Note that it would typically require at least 2 blocks between the request transaction and the response transaction by the relayer, which will trigger the callback. In this example, the callback will simply store inside the total state variable the result of addition between the decrypted value and the 2 custom unsigned integers, input 1 and input 2. That's all for today. Stay tuned for more information on fhEVM releases.